Next, I need to remind you about the use of prefixes. While we may not use all these prefixes in the first semester of physical chemistry, some of these are certainly becoming commonly discussed in the news, especially when referring to digital data storage and computer speed. Everybody has heard about megabytes, gigabytes, and now terabytes, and some of you may have even heard about petaflops to report the speed of modern supercomputer CPUs. In chemistry, we frequently use kilo, deci, milli, micro, nano, pico, and femto. So you will need to memorize all prefixes in that table. As usual, to motivate ourselves to review this topic, it may be worthwhile to recall why we are using these prefixes in the first place. For example, let us look at the following number of moles. We can write 1.3 10 to the minus 5 mole as 13 10 to the minus 6 moles, or 13 micromoles. Alternatively, you can also write 1.3 10 to the minus 5 moles as 0.013 millimoles. So we are using prefixes to shorten the representation of numbers using specific prefixes to represent specific powers of 10. The availability of prefixes based on the power of 10 is one of the many advantages of SI units over other systems of unit. There will be many instances in this course where you need to carry out prefix conversions. So let us practice this type of conversion. For example, let's express the area given by 2.1 square millimeters in the SI unit of square meters. We know 1 millimeter is equal to 10 to the minus 3 meter. So 2.1 square millimeters is equal to 2.1 10 to the minus 3 meter squared, which is equal to 2.1 10 to the minus 6 square meter. Now, let's just express the volume, 1.1 cubic centimeter, in the SI unit of cubic meter. We start by writing 1 centimeter is equal to 10 to the minus 2 meter. So 1.1 cubic centimeter is equal to 1.1 times 10 to the minus 2 meter cubed, which is equal to 1.1 times 10 to the minus 6 cubic meters. Besides carrying out prefix conversion, you will also need to practice unit conversions using conversion factors. You will need to memorize the conversion factor from the SI unit of cubic meter to the non-SI unit of liter. 0.001 cubic meter is equal to 1 cubic decimeter is equal to 1 liter. To help you memorize these quantities, it may be useful to visualize such volumes. 1 liter is about equal to a quart. A cubic decimeter is the volume of a cube 1 decimeter aside. A decimeter, recall, is a tenth of a meter, or 10 centimeters, and that is just about 4 inches. You will also need to memorize the temperature conversion between degrees Celsius and Kelvin. The temperature in degrees Celsius is equal to the temperature in Kelvin minus exactly 273.15. All other conversion factors will be provided to you during exams and can be found in your book for your homework assignments. You should in particular practice converting pressures from one unit into another. For example, let us convert 3.54 atmospheres into pascals. We know that 1 atmosphere is equal to 101,325 pascal. So we write P equals 3.54 atmospheres times 101,325 Pascal divided by 1 atmosphere. We cancel the atmosphere units and multiply out the pressure in atmosphere units by the conversion factor to obtain P equals 3.59 10 to the power 5 Pascal, or 0.359 megapascals.